Today we'll be able to find nth roots. First of all, as a warm-up, so pause the video, see what you can remember about solving these radical expressions, and then come back and check your answer. So we want to find a perfect square root that goes into 48, 16, and 16 times 3 gives us 48. The square root of 16 is 4, so 4 square root of 3. On this one, it's the same thing as multiplying 12 times 3. So the square root of 12 times 3, square root of 36, would be 6. And we can rewrite this expression as the square root of 16 over the square root of 5, which is 4 over the square root of 5. We cannot leave a square root in the denominator. So we do what's called rationalizing the denominator by multiplying the numerator and the denominator by square root of 5. So our answer is 4 square root of 5 over 5. Our key concepts. This number, if it doesn't have a number here for an index, it's understood to be a 2. Our radical sign, and then what's underneath the radical is the radicand. For any real numbers, a and b, and any positive integer n, if a to the n is equal to b, then a is an nth root of b. If n is odd, then there is one real nth root, and if n is even, there are two real nth roots. The radicand is the number under the radical, index is the degree of the root, and the principal root is the positive root when the number has two real roots. So if there's an even index, if you've got a 16 here, it would be like positive and negative 4. The principal root would just be the positive 4. Okay, example 1. We're to find all the real cube roots of this number. So since 3/10 to the third power is equal to 27 thousandths, the cubed root of 27 thousandths is 3/10. Since the negative 5 to the third power gives us a negative 125, then the cubed root of a negative 125 is a negative 5. 1 over 64, since 1/4 is the cubed root of 1 over 64, or 4 to the third power gives us 64, then the cubed root of 1 over 64 is 1/4. Find all the fourth roots. Okay, so when we have an even root, it will make a difference in whether or not this has an answer. Let's start here. Do you know what the fourth root of 625 is? How about in your calculator, you go 625 to the power, open parentheses, 1 divided by 4, close parentheses. Tells us 5. 5 to the fourth equals 625. So if you ever get one of those mind blocks and can't remember what the fourth root of a number, or a fifth root, or a sixth root, whatever, do it to the fraction, the power of the fraction. Now this is an even number, so we're going to have two roots, positive and negative 5. Since this is a negative, this is an even root with a negative number. There is no real number with the fourth power of this negative number. So whenever this is a 2 or a 4 or 6, even any even number, you cannot have a real root to a negative number. The fourth root of 81 is 3. The fourth root of 625, as we've already learned, is 5. So the fourth root of 81 over 625 is a positive or negative 3/5. Remember, it has two real roots, both a positive and a negative, when it's an even index. What is each principal real number root? Okay, so let's study this. We have an odd index, so we can't have an answer when there's a negative. Negative 3 to the third power gives us negative 27. So our answer is a negative 3. Our index is even, and they're asking for the principal real number root, so they're only asking for the positive number, 3/10. Even index, negative number. So there is no real number with a fourth power of negative 16. Even index, even power. So negative 3 squared is 9. The square root of 9 is 3. And remember, they're just asking for the principal, so not the plus or minus 3 or positive and negative 3, just 3. Another key concept that we noticed in the previous, if we've got the same index as we have a power, then the answer is just the radicand. If n is even, though, and then it's going to be the absolute value of a, if both of those are even. Simplify each radical expression. Okay, so we've got an odd index. What number times itself 3 times gives us 27? Why 3? We can rewrite this as 3ab to the third power, right? Now we have the same exponent as we do index, so that means our answer is just 3ab. So if you try to break this out into whatever our index is, then we know what we can pull out from under the radical. Looking at this one, we have an index of 4, so we can rewrite our x as 4 times 4, and y is to the 4th. So now we've got our 4's as exponents. We can rewrite this as x to the 4, y, all to the 4th power, right? Now this is an even index, even power, and this is odd. So whenever you see even to the odd, y to the 1, we have to put our y in absolute value symbols. Okay, very good. You're ready to begin working on the exercise.